Hey guys, Sal Subnis here with SS Multimedia. Today we're going to be talking about the meanings of multiplication and repeated addition. Okay, so our objective today will be understanding multiplication and its similarities to repeated addition. Okay, so we're also going to be figuring out models for multiplication, and that will go under the umbrella of multiplication. Okay, so the first thing we're going to be doing today is figuring out what is multiplication and repeated addition. Okay, just to make sure we understand. Okay, so we're going to have this one as multiplication and this one as repeated addition. Okay, so now first we're going to be doing multiplication. So what is multiplication? Okay, so that is basically equal groups. Equal groups being put together to form a total. Okay? And of course that total in multiplication is called a product. Put together a product. Okay? So that is what multiplication is. Okay? So I'm going to do an example here just so you understand. So we have 2 times 3. Okay, so what can this be shown as? 2 equal groups. So say we have 2 grocery bags. Okay, 2 grocery bags. And in those grocery bags, we have 3 apples in each. Okay, so I'm not too good at drawing apples, but try to imagine that as an apple. Okay, so, I'm just going to draw circles in this one. It's a lot easier. Okay, so now we have to put these two together. Okay, so now the question here is, what is the amount of apples that you bought completely? Okay, not how much did you spend, how much did you get? Okay, so how do we figure that out without using addition? That's multiplication. So if we know that we have 2 threes, so that means there's 2 groups of 3. So that means we just have to add those 2 together, which is also basically multiplying it by 2. So 3 plus 3 is the same thing as 3 times 2. And that is the same thing as 2 times 3. So if you, in the beginning of multiplication, if you struggle with the idea of multiplication, it's easier sometimes to just start with this. So say we have 3 times 3. And you want to use that as an addition, what would that be? 3 plus 3 plus 3. And now the question here is, what is that? That is repeated addition. Okay, so addition is the same number being added multiple times. The same number being added multiple times. Being added multiple, I'm going to abbreviate that because you're getting tired of seeing me write multiple times. Okay? So now we have to figure out what is 3 times 3, or let's figure this out. First, let's figure out what is 3 times 2, or 2 times 3. Okay? So that would be 6. How do I know? 3 plus 3 equals 6, meaning 3 times 2 equals 6, meaning 2 times 3 equals 6. They all have the same answer. And that would be right because they're all equal. Okay? So that means 2 times 3 would equal 6. So that's how you know what multiplication is and what repeated addition. Okay, so now I'm going to go deeper to multiplication and explain the models in multiplication. So we're going to start off with something simple. These are called arrays. Okay? So these are basically combinations of multiple symbols. So an array could be formed, as you can see, it was formed using X's, but it could also be formed using stars, circles. So this could be an array. This could be an array. Like that. There's plenty of ways, anything. If I could draw a good fish, you could use fish. Okay, I can just use a letter. Letters could be used like that. F, 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 and F, right? Although letters could be used as variables, so it's not advised to do that. But my point here is that any symbol can be used to create an array. Okay, so today our model problem, to help us understand all the models, I guess so our example will be 3 times 4. Okay, so our example will be 3 times 4. So we're going to be focused on 4 today. And as you can see, we have 1, 2, 3. So we have 1, 2, 3, 1, 2, 3, and 4. That's not a coincidence. 4 and 3, 4, 3, not a coincidence. Okay, and as you can see, can be done the same way here. 1, 2, 3, 1, 2, 3, 4. Okay, 3 and 4. Okay, so how do we use an array? Well, one, you could just use counting, right? But this is mostly a way to show what you're trying to do. Okay, there are more effective ways to do it, but this is a good way to start because this is what's used mostly during life. So, say we have 2 times 3 would be like this. 1, 2. 1, 2, 3. Okay, so it has to be 2 and 3. It doesn't matter which way. Right, so you have to have those two factors. Okay, what is a factor? The two parts, the two equal groups that are being put together to create the product. Okay, so you have to have those two products. So 2 and 3 could also be like this. 1, 2, 1, 2, 3. You still get those two numbers. Okay, so now, of course, now we have to figure out what is 3 times 4 using this. Okay, and now that's actually kind of simple. We have 1, 2, 3, 1, 2, 3. That would be 6, 7, 8, 9, 10, 11, 12. Okay, so if by the end of this you get 12, that means 3 times 4 equals 12. Right? But we can also count it in a different way. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we get the same number, just counting in a different way. Okay, now that's called what I did here in the first version with the blue color. That is called counting by threes. And what I did here with the red, that's called counting by fours. Okay? So, now that we know, since we got the same answer with both, it's always good to double check in case you missed the X or something like that. We got the same answer both times. That means 3 times 4 equals 12. Okay, so now of course we're going to use another model that's called equal groups. And we're going to use the same model problem even though we know the answer, just because it's easier to stick with one problem when you're trying to demonstrate. Okay, so what is equal groups, right? So now as I explained to you with the apple and the handbag, the apple was one equal group because there are 3 apples in both groups, right? And there were both 3 equals 3, and there is one grocery bag here. Okay, now of course, if you go into more fractions, it's not an equal group if this is the group, and it holds 2, and this is the group, and it holds 5. Okay, then it's not equal because 2 and 5 are not equal. Okay, so one of the grocery bags could be this small, and it would still be able to barely hold 3 apples. This one would be able huge, have lots of space, and it would hold 3 apples, equal groups. Okay, because with that model, we can still do 3 times 2 equals 6. Okay? So now we have to use this or this. So these are 2 different things. We have to use one of those to figure out what is 3 times 12. Okay, so now to figure this out, we're going to have to use the equal groups using multiples. Multiples is basically, I can't think of any other better way to describe this other than what comes next. So you have 5, 10, 15, 20, 25, and etc. It just keeps going. Okay? So that would mean that 10 Multiple of 5, why? Because you can add 5 to 5 to get 10, right? 15 is a multiple of 5 because you can add 2 5s to get 15. But why is 13? Okay, so say, why is 13 not a multiple of 5? Because if you add 5 plus 5, you get 10. So you go to the next one, you get 10 plus 5, you get 15. That completely skips this number, so that means 13 is not a multiple of 5. So that's how we're going to do this. We're going to count by multiples. Okay, so it's basically what we did with the array, but in a quicker way. So we have 4, then 4 plus 4 is 8, 8 plus 4 is 12. Okay, now we can do this with the 3's. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. We're getting the same answer both times, which means 3 times 4 equals 12. Okay, so now we're going to do the last method here, which is called the times table. And we're going to be using the 3 times table in this one, okay? So now this one looks a little confusing when you first look at it, but once you take it in, this can be very, very helpful, okay? So now I'm going to write these each as a multiplication. So I'll just do these first 3, each as a multiplication and as a repeated addition problem. Okay, so let's figure this out. What is 3, 1, 3? What does that even mean? Okay, then 3, 2, 6, 3, 3, 9. It's just random numbers, right? Not so. That's wrong because it is a factor. Like as I said, so I'm going to explain this a little better here. You have 3 parts of an equation. Okay, so this part is the total, and then these 2 parts are the parts that gum together to create the total. Okay, at least in addition and multiplication. Parts together that come to the total. Okay, so in addition, this part would be the sum, but we're talking about multiplication. So the total would be in multiplication words product. Okay, and these 2 are called factors. Okay, but I'm going to write here factors. Okay, but I'm just going to write F because I don't want to write that too many times, so it's F into F. Okay, so now what we do, we know that this is the first factor, right? So this is the first factor. So we're going to do 3. This is the second factor, that is 1. And then now the beauty of this, you already have the answer in front of you. 3 and 1 is 3. Okay, so now when you add the symbols together, right, you have the multiplication symbol here, you have the equal sign here. So if you have the equal sign and that number afterwards is 3, that means 3 times 1 equals 3. Now you can do that with all of these. 3 times 2 equals 6, right? That would be this one, 3, 2, and 6. That's our answer. And then 3 times 3 equals 9. Okay, and that applies to every single one of these. We could do any random one. 3 times 8 equals 24. Okay? Now I'm going to show you this in repeated addition. Okay, so now, what does this say? It says that 3 is done 1 time. Okay, so if the first factor is 3, that means we're trying to the second number designate how many times we're writing 3. So if it's 3 times 1, that means we're writing 3 down 1 time, then we're putting the equal sign down. So this one's pretty simple. I'm guessing you should know this. If not, then I don't know what to do. So 3 equals 3. That's the most basic you will be getting in 4th grade. Okay, then you have 3, 3, 2, 6. So that means 3 is done 2 times. So now, after you get these 3 done 2, then you put the equal sign. So you have 3, 3, then equal. And then you figure out 3 plus 3, okay, that's 6. Okay, now this is where it gets a little more tricky, but it helps a lot. 3, 3, and 3. That would mean 3 is done 3 times. But instead of having to write 3, 3, and 3, you can do 6 plus 3. Okay, and then, why? Because 3 2 times is 6, and we're doing 3 times. So if you already know what it is 2 times, you just need to add 3 one more time. No point adding it up all over again. Right? So we have 6 plus 3, that would equal 9. And how do we know that's right? Because would be 9 if we got it in multiplication too, right? And now you can do 9 plus 3 instead of having to write it that many times. But of course that doesn't become repeated addition, but it is a good shortcut. But you can only use it when you're using times tables. So that's why I like this method the best. So once you memorize this, anybody asks a question to you, you can answer it. So any question you should be able to answer as long as you have these memorized. Right, I'm going to pick a random one. 3 times 19 would be 57. Okay, and now we test this. We have 3 times 19. And this is actually a good way to show you long range multiplication. How you do that? You break it apart. So this would equal to 3 times 10 and 3 times 9. Okay, so 3 times 10 is 30. And 3 times 9 was that? 27. How did I know 3 times 10 was 30? Because 3 times 9 was 27. So 3 times 10 would be 30 because it's a pattern of 3s. Right? So now we have to add these two together. So 30 plus 27, you have 7, 5, 57. So that means, like I said, 3 times 19 is 57. So if you get these memorized, you can answer any multiplication product. Of course, this is only 3s, but it is a good way to start memorizing your times table. Okay? So like I said, this was multiplication. So this was the multiplication part of it. And this was the repeated addition. I'm just calling it RA here. Okay, it's an abbreviation. Okay, so now you know what does multiplication mean in its basics. You know how to do basic multiplication. And you know what repeated addition and its advantages are. And how you can use that to help learn multiplication. Okay, so there you go. We have completed our objective. Our objective here was understanding multiplication. Okay, so let's do a checkbox here. So this was number 1. Okay, so 1, we have a checkbox there. This one is similarities to repeated addition. That's 2. We only have 2 major things, and I think we got it done. I'm guessing you know what multiplication is now, and you should be able to do basic stuff. So that means we got our first one done, and it's similarities to repeated addition. You should know that, seeing as it's almost the exact same thing. Okay. Alright folks, thank you for watching this video. Please like, share, and subscribe to our channel, and have a great day.